Okay, so I'm going to give a short talk on the software for the glass software for the GNSS-EPOS TCS project. Okay, I'll just begin. So the idea is to give a short overview, not mainly from an IT perspective. So I hope I don't lose people along the way, but if I do, please ask questions at the end. So what is glass? This is a software project, a software package developed in the EPOS project. As Rui said this morning, its name has a somewhat strange history, but this is the acronym Geodetic Linkage Advanced Software System. So the idea is based on a concept of integrating distributed repositories. So all the GNSS data and products are physically stored on local nodes and integrated in a distributed fashion. So the whole idea of this data is to collect data, metadata and data, insert it into some sort of database, validate the data, distribute it amongst the various nodes, and disseminate the results. Data redundancy is built in, so you can define your primary, secondary, or mirrored repository for a certain GNSS station or even for a RINEX file. There are tools for data monitoring and data quality control. So the design choices at the beginning were to have a centralized submission and validation of station metadata, which would be validated before it's inserted into a central node called the data gateway. So the actual nodes themselves don't insert or don't need to insert station metadata locally. They do it all through M3G, and the idea is that it's a distributed and synchronized process, so this metadata should appear on their local nodes. Quality control was also thought of at the start. So the idea is that users only have access at the main portals to high quality data and products. So products that have data, for instance, data files that have a certain status, that have a certain number of constellations or GNSS satellites that have passed certain data checks. And also all the data, the local data and the RINEX files, the local nodes all keep full control of all these RINEX files. So they're not stored or they're not given away or whatever. They're not stored on a centralized server. They're just, the local nodes retain complete control. So you've probably seen this diagram before, which just shows you a quick, well, not really a quick, but gives you an idea of the flow within the system. So data providers have to validate their station metadata M3G. This is then entered in at the GNSS data portal, which is running a glass node, and also at the products portal, which is also running a glass node. This metadata is then sent to the individual data provider nodes. The providers provide RINEX files, which are processed at these nodes here. Metadata is then sent to the RINEX file metadata is then sent to the GNSS data portal. Okay. So these are the current installations of the glass software at these data nodes. So we have the data gateway, the principal user gateway for accessing RINEX file metadata, obtaining URLs, obtaining station metadata, etc. These are a list of the individual nodes that are currently installed. Another way of looking at this, these are the main user portals, as you've already seen, are the data gateway, the EPOS data gateway, the product portal, which will be discussed in more detail tomorrow. There is also another meta portal, which is the EPOS Integrated Core Services Data Portal, which integrates services and products and data from various communities within the EPOS projects: geology, geomagnetism, geodesy, anthropogenic hazards, near-fault observatory, seismology, volcanology, etc. So here you can see, for instance, that this portal enables access to some of our web services, for instance, the data, the station metadata, the RINEX file metadata, and some of the products, for instance, the time series. If you click on, actually here, it will plot the time series for you. The velocities, strain rates aren't available yet. But this is a work in progress. It's EPOS ICS data portal. It has an integrated workspace. So in the future, people will be able to open Jupyter notebooks and process files from several communities, search for data from several communities, all based on the different communities supplying web services and data and products. So all this is based on being able to search for the data and products and the metadata. So basically, we have there is a set of the glass nodes are running a searchable application called the Glass API Application Protocol Interface. So a whole set of web services which can be viewed in Swagger format here, so you can try it out, and you can look for the service that you may need. So if you want, you can build your own Python or Node applications or shell scripts. As a previous question from the previous talk was asking, how you might use all these web services to check how many files he has on a particular day for a particular station, compare that at a previous snapshot or to a previous day. You can build all your own personalized applications with these web services. All the GUIs, the portals, are built on top of these web services. Okay. So the software components. The various software components, well, we have a common database structure, which stores data in various categories. For instance, it stores data related to, or metadata in this case, related to network topography or topology, characteristics and connections between the various glass nodes. And then we have metadata derived from the IGS log files. So the station metadata, station name, antenna details, when the station was installed, when it started disseminating files, etc. RINEX file metadata is another category. For instance, when the file was created, its hash, MD5, its URL, where it can be obtained from. RINEX file quality data, the file status, if it's considered good quality or not good quality. We have a simple numeric scheme, -3 to +3, to describe the overall quality or status of a RINEX file. And then we also have the product data, raw and clean position and position time series, velocities and strain rates, which are also part of the common database structure. So on a glass node, we will have servers and software to manage, validate, and distribute GNSS data and metadata, and if necessary, the associated products. There is also the concept of a data center. A data center is just your current data store for your RINEX files, and a file server could be a HTTPS file server or SFTP file server for disseminating the actual RINEX files. So the overall architecture. So here we can see a glass node. Okay, this is a glass node. It has a database, GNSS Europe database. There's a web application, a REST web application, the Glass framework, running on a Glassfish web server that is used to query the database. On top of that, we have clients, for instance, the Glass web client, which is used at the data gateway for visualizing the data, the RINEX file and station metadata, as Mathilde just explained in the previous talk. And this can also be accessed via Python, by bash scripts or whatever, using REST API calls. So the EPOS portal is doing that. So this is the application to query data, disseminate data, and these are the web applications built on top of it. A separate application is used to insert data, and this has several applications that were developed in order to access this web server and insert data, in particular for indexing RINEX files and for inserting the quality data. As well as this, there is a synchronization service that synchronizes parts of the database between the various Glass nodes. In particular, for instance, the station metadata is synchronized from the EPOS data gateway to the individual nodes, and the RINEX file metadata is synchronized from these nodes to the EPOS data gateway. We also have the concept of a data center where the RINEX files are stored and where they are actually disseminated via some sort of file server. Could be HTTPS or SFTP. Okay. So that's the overall architecture. So the database is based on PostgreSQL. Consists of a set of typical relational database, consists of a set of SQL tables, and also a set of triggers, because the synchronization service is based on database triggers. The Glass Framework API is a REST API. By default, it runs in a Glassfish Java Enterprise Edition container. You could actually also compile it for Apache or Nginx or some other server. By default, it will also come with a Swagger server for users to help users query the data directly using API calls. Other web applications that can be installed are the Glass Web Client, the GUI for visualizing and searching data, and an optional web application, a node manager, which manages the node and data center details. In principle, by default, the Glass nodes, the EPOS Glass nodes, shouldn't need to install this application, because all these details, the node and data center details, should be synchronized automatically from the data gateway. So what will happen is when a new Glass node wishes to join the system, it will contact the data gateway administrator, Jean-Luc, and organize with him and discuss with him and fill in a set of node and data center detail papers with technical details to connect the various nodes. Metadata insertion. So only the EPOS data gateway really needs to insert station metadata, because it will then be synchronized down to the local node. But of course, for testing purposes, you might want to test this, which you can always do, of course. Glass nodes, or the EPOS Glass nodes, only really need to insert RINEX file metadata and quality data. How is this done? is done using a Python web application. You can run it in Flask or some other Python server. So this exposes an API to two applications that are called IndexGD and RunQC. IndexGD is a small Python script to extract runx file metadata and insert it into the database using the web API here. RunQC is a set of Perl scripts that call Anubis. Anubis will create a quality check, a quality report on the individual runx file, and this data will then be inserted into the database via the Flask web server application. In fact, I should say at this point that most of the data that is actually contained in the database is in fact quality data. A large percentage of the data is this quality data. And it's one of the reasons why this quality data is always kept on the local node. It never arrives at the data gateway. The data gateway will only receive a summary of the quality data, in particular a status of a runx file. In fact, the runx file metadata is only sent to the EPOS data gateway if it's considered good enough quality. So a status, or a positive status, we call that. So why do we have two servers? Well, that's one of the reasons. Was EPOS was a large project, many different European partners, and each partner obviously free to develop the applications on their own with some sort of central coordination, and also for security reasons. So obviously the GLASS framework has to be exposed some way to the outside world. So there has to be some sort of routing for queries to arrive at this server here. The insertion, the actual server that makes the insertion, that can be completely hidden from the internet behind some firewall. However you want to configure the network. So it's another good reason to have a separate web server for this process. Finally, the synchronization service. This is a simple Java tool for synchronizing metadata between databases. So the node topology and station metadata in the EPOS system will flow down to the local nodes from the data gateway, whereas the runx file metadata generated at local nodes will flow up to the data gateway. This is in fact a much more simple process than this one, because obviously at this point we have to know which stations are stored at which nodes and only synchronize those stations to the correct nodes, which is not as simple as it sounds, and was one of the reasons why we decided to develop our own database synchronization tool rather than use one of the commercial offerings, or even why we couldn't really use the Postgres integrated replication services that are offered when you just install Postgres, for instance. The T3, the quality data about a runx file is not synchronized. This, as I stressed before, this remains held locally. The local nodes must disseminate the runx files public. Obviously, we can have embargo dates, so that's also contemplated within the software and within the database. But in general, the local nodes must disseminate the runx files publicly via some sort of web server, file server. So just to make a quick review, metadata, station metadata is inserted at the M3G center, the IGS log files. These log files are then added to our database at the data gateway. This metadata is synchronized, the station metadata is synchronized to the local nodes. These local nodes insert RINEX file metadata. It's processed and then synchronized to the data gateway. The various analysis centers obviously can also use all of this data at the data gateway for computing time series and velocities, strain rates, etc. The day-to-day processing. For day-to-day processing of incoming RINEX files, of course, we have basic scripts to extract metadata, IndexGD and runQC. But this is can be quite a complicated process. And these scripts are designed and they contain many options for processing daily and historical data. You can run these scripts over a set of directory trees. But for daily processing, we have other projects, for instance, a small project called GNS Indexer, or another project for daily processing of RINEX files arriving at some sort of bucket directory and then are processed in some standard way. So as well as these basic or fundamental tools here, IndexGD, runQC, the Flask and the Glass API, and the database and the synchronization service. We have developed a whole set of other tools and projects that might be useful for people running Glass nodes. Okay, if you're interested in installing this software, well, the background, it's loosely based on the original GSAC software concept from UNAVCO. I say loosely because it's basically just the idea of GSAC, having a database, an API on top of it. But the database, the way of compiling, the way of installing, of course, is completely different. As Rui said this morning, the Glass package is open source. You can install it all on one basic Linux server with an internet access. By default, we have tested everything on a CentOS 7 server with 8 gigabytes of RAM. But of course, you can install it any way you like. In particular, you can install it in a distributed fashion. You can install your database on one server, your web application server, Glassfish on another, your Python web server on another. You can run your Python and Perl scripts in on different boxes. So you can basically distribute it over as many servers as you wish. Depends really on your IT setup. All of our projects are currently on a software repository, GitLab. So gitlab.com/GPS Europe. So all of our software projects, including the compiled versions of the applications, so you can either compile from source or you can use the pre-compiled tools, the pre-compiled versions that exist. They're all currently now open source, so you can obtain them, fork them, post issues. If you want to become a developer, obviously you will have to ask, request permission to become a developer, but you can download all the software at this address. The installation process, what will you need? Well, you'll probably need some sort of Linux box, Linux box, if you prefer the American pronunciation, CentOS 7 or something similar. You'll need a Java runtime. You'll need Python 2.7 and you'll need Python 3. You'll need Perl, you'll need C++, unless you go and get the Anubis pre-compiled. If not, you'll have to compile it yourself. You'll probably need a Git client. you'll need to install a PostgreSQL server. Then you'll need to install the database and activate the database triggers or not. If you're just interested in experimenting with software, you won't have to synchronize your database, so you can decide to install database triggers at a later point. You'll need to install a Glassfish web server or compile the code for Apache or Nginx or some other web server. And then you'll need to install the optional GUI if you wish. You'll need to install a Python web server or some other Python web server. Flask is a basic Python web server. You'll need to install these Python and Perl scripts and the Anubis software at Jandoza's site in Czechoslovakia. You'll need other tools, other software that might be necessary. Well, it is necessary, the Hakanaka compression, other standard compression tools as well. You'll need to install our Java Synchronization Service as a compiled version, or you can compile it yourself. We have software to test to run basic tests, and it's all on our GitLab. So if you're really interested in installing, you can install all this software, run the test tools that we have. Afterwards, you can install your station metadata at M3G, install the synchronization service and triggers, wait for synchronization from the EPOS data gateway after signing the EPOS node letters and supplying the relevant technical details. After that, you will eventually receive your station metadata, which you can visualize or query using the API. After which you can start to insert your Rhinex file metadata at the local node. And run the data quality tools as well. So the guidelines for setting up and operating an EPOS GNS data node can be found at the M3G site at this address. Software installation, there are some documents available on Google we will share for describe the process in a bit more detail. There is also a virtual machine available with all the software pre-compiled and ready to roll at this address here. So this is the site. You can obtain a Vagrant box. So this is based on Oracle VirtualBox. So if you're just if you just want to quickly try this, you can install a virtualization software like Oracle or VMware, install Vagrant, and just quickly get a Vagrant box running. If you're interested in OVF, you can download the OVA file. So that's also available. One of the main difficulties with this type of installation is security and port forwarding. I'll give a quick demo of the virtual machine in a minute. Of course, this has to be exposed to the. So you'll want to, for instance, this is a typical virtualizing environment. Some sort of host here, a virtual machine running the various software. Up some sort of port forwarding to expose this to the internet. Depends what services you want to expose. So like the Glassfish API, or if you're running your own product or data portal. If you want to this software, then you won't need to worry about this sort of forwarding. You'll just need to access the
your virtual machine within your host. If you're using Vagrant, it comes already so you can just quickly log on via SSH client to your virtual machine and start experimenting with software, and you can access the software from your host with some sort of browser or whatever. I can give a quick demonstration of this. So, if you're using like me, Oracle VirtualBox, Vagrant is a quick way of setting up a virtual machine. So you can just download that virtual machine. If you need to, you can customize your Vagrant file. If you want to customize port forwarding, etc. By default, this virtual machine will have two EP addresses, one on some sort of local network, visible only within the virtual machine. And in this case, I will be able to access the virtual machine at this address on my host. So using the virtual machine with the defaults is just as simple as saying Vagrant up. This will boot the virtual machine. Okay. Once you boot the virtual machine, you should be able to access the virtual machine via a remote shell. In this case, SH secure shell. Once we log in, we can see the EPs of this virtual machine, two EP addresses. I have a whole load of scripts and aliases to control or to help configure a glass node if you want to use different EP addresses. For instance, you might want to have a different external EP address. So you might it depends all on your site's routing, but this can be some sort of external EP address completely different from your local EP address. But this might be important, for instance, for the GUI, which is an Angular application, and for your Glassfish application. So you can log on. So, as I said, all the software comes pre-installed in this directory, EPOS directory. The relevant passwords are here for the virtual machine, for the applications. We have simple scripts like, for instance, start Glass, which will just check your Postgres server is running, the database is installed. It will start the Glassfish server if necessary. It will also start the Flask web server if necessary. We have a whole set of tools called test that will test station metadata upload, modification, deletion, Runx file metadata upload, quality file metadata upload. So this is the result of running this project here. So this is inserting data into the local database. This can then be queried. So on my host, I'm accessing my virtual machine, the Glassfish, the Glass Framework API at this address. So basically here I have all the applications I might need, the Glassfish admin console if I need to, the Flask web server and its API, so a small API for for inserting metadata, and also some basic queries. The GLASS Framework API, so some information about this should contain information about what sort of data the node is servicing. Here you can see the Swagger API. So let's choose a web service, list stations, try it out, execute. So here we have the result of the stations that were inserted with this tool behind us. Okay, back. The data portal on the local node. So these are the stations that were inserted by this tool here. So I'm not going to explain this again because Mathilde has explained this data portal, this GUI already. Just one thing, it's an Angular application, so Node.js single page application. There is an application for running, sorry, for querying topology and data center and data node information. Sorry. So let me just show the data centers that were installed by this tool behind us. So we can see here the data centers installed here. So this is the data center for C4G at UB. Okay. We want to run some API queries, for instance, this query, which is obtaining all the Rhinex file information from these two stations. We can run this sort of queries in a browser or from a command line tool, Python or Node or curl or wget. So this is querying the Rhinex file metadata. If I click here, in this case it won't work because I don't have the virtual machine doesn't have a FTP server or file server conveniently configured, so that won't work. This is another query that listing all the stations currently in the database. So that's just a quick idea of using the virtual machine. There are other data and tools available on the virtual machine. I can show you.
Oh, Paul, just 3 minutes or
yeah?
2 minutes? Just 2 or 3 minutes.
Okay, then. Okay, then I'll leave that example for another day, and just go back to the presentation. As has been said before, the actual installation process, I'm not going to deny that it's not. It does have its complexity. It's necessary to install and configure a whole set of servers and scripts and tools. So you'll definitely need some sort of help if you're willing to install a GLASS node. So if you have an IT center, I'm sure they can help with configuring Postgres or Glassfish servers, running or installing Perl and Python, etc., securing the whole services. But we do have a solution for for data providers that, for instance, only have a small number of files to make available. They're not willing to go through all the trouble of running a glass node, which this solution we call the glass pan-European node. And so a glass node for providers that are not willing to host their own node. So in this case, you will need to contact one of the people responsible for this node and ask if it's possible to make your files available. You'll have to make, you will have to organize some sort of way of making available or letting us access your Rhinex files in order to extract the relevant metadata and run the relevant quality tools. And then all this can be synchronized and made available at the data gateway. So this is the current glass pan-European node. So it has a local GUI, like all the nodes can have a local GUI, a local graphical user interface, a local data center. But really the best way to access this data is through the data gateway portal. Finally, contacts. For installing an EPOS glass node, the best contact to start with is Jean-Luc at Nice. Questions on the software. Obviously, you can raise issues at GitLab, or you can contact myself or my colleague, José Manteigueiro. Okay, so I'm finished.
Okay, Paul, thanks very much. We have some questions. The first one is by David Comis. David. Yeah, David. Hello.
Maybe you can tell.
Hello. Hi, Paul.
Yeah. Hi.
Hi. Just one question. The synchronization between the nodes, the gateway and the local, when it's done, it's a kind of trigger in the database, or it's?
Yeah. So when data is inserted in this local node, inserted into this database, the database triggers will create queries that are stored in separate tables. And then whenever you run the synchronization service, so you don't have to run it every day. You can run it periodically. You can run it as a service, or you can run it as just a software that you run on a cron tab. It's up to you how you run it, as on a cron tab, on a service. Yeah, so you can run it however you like, and with a free, you can even run it as a service, say every half an hour. So it's really up to you how you configure it. You configure the execution, and it will extract the queries that have been created by the triggers and insert them into the database at the data gateway.
Okay, and from gateway to the local node,
it's the same sort of procedure. It's the same sort of procedure. So at this node, there'll be another synchronization service that will need to access your database and insert the updates to the station metadata, insert any new stations that you've inserted at M3G, and so on.
Okay. Thank you very much, Paul.
Yeah. So this connection here, obviously you'll want you can use your Postgres tools to really make it secure. You can make a firewall connection, only letting your database be accessed by this IP at this address. You can use, it depends. Security is a big topic. I don't want to discuss it all, but I mean, there are many ways that you can secure this connection. Even with I don't know, with keys,
firewall rules and this kind of things. Okay.
Yeah.
Very much.
Okay.
I should say that, for instance, the Estonian node, this security is they're very security conscious in Estonia, and this sort of connection has to be really secured, not just with firewalls, but with SSH
keys, and so on.
Okay.
So
Okay.
yeah, you can use EPSEC. You can. I mean, there are many ways of.
Yeah, sure. Yeah, thanks.
Okay, so there was a second question, but the person is not available anymore. So maybe tomorrow we can do that.
If you want to read me the question, I can answer.
We can leave for tomorrow.
Yeah, tomorrow. If he's not there, so we have time.
Yeah, because
for tomorrow. Yeah.
tomorrow we will have a session. The final session will be from with question and answers, and I think there we can have a more broad lack of questions that can for all the people. So we are already saving some of the questions for tomorrow, and I think for today we are on the schedule to finish. I really have to also to thank all the people that has been present. We hope for the ones that is already late, a good night's sleep. For the other ones, a good rest of the day, and we will be here at the same time tomorrow for our last presentations, and after for the questions and answer session. So please write down everything that you would like to ask us. We will be here to answer as best as we can. And I wish you, as I say, a rest of a good day, and see you again tomorrow.
Okay. Yeah, they don't speak back, but bye.
Yeah, exactly.
There's no reaction. Maybe, yeah, people are writing. Thank you.
Okay.
We have feedback. Yeah.